Let's get started. Hi, my name is Jinhyun Park, and today I'm gonna have a presentation on green bioplastics. So, can you guess what it means from the name? Well, I think that most of you guys would say yes, since the concept of green bioplastics is quite a familiar concept with most of us these days. So this is the contents that I will cover today. So I'm gonna start from the introduction about the background and need for green bioplastics. And then we're gonna move on to the body part, which is about what the bioplastic exactly is and how can we develop or produce it. And finally, we're gonna end this presentation with the conclusion part, which has some brief summary. So now let's get started. So why do we need green bioplastics? Well, these days, environmental problems caused by plastic waste is becoming a growing threat. That's not very surprising considering the amount of plastics we use in our daily lives. So we are using too much these days, right? So most plastics we are using now are not biodegradable. So basically, they do not degrade it into CO2 and water in nature, and that's the reason why the amount of plastic waste is causing a serious threat in these days. What's more, some of them take even more than 100 years to be fully degraded. So, wasted plastics do not degrade to CO2 and water, and instead, they are just accumulating in the landfill or environment as a waste. As a result, only a few, maybe about 21% of the total amount of plastic waste is recycled, and the remaining is just released to the environment with harmful bioproducts. The problem is that the amount of plastics we use today is sharply increasing as time passes, and so do the amount of plastic waste. So, the problem is just getting bigger and bigger as time passes. This is a huge problem not only for the environment or for the earth, but for our own healthcare as well. Many tiny little plastics, which is called microplastics, are floating in world oceans or accumulating in landfill, and then there they enter into our food chain by entering into our food resources such as fish, salt, sugar, honey, water, etc. Eventually, they get into our body, causing lots of diseases and even deaths. Don't you think it's too dangerous and scary? Furthermore, today most plastics are produced using fossil fuels by petrochemical industry, and that obviously increases the amount of carbon dioxide released to the atmosphere, and thus making environmental pollution even worse. So clearly, we need to take some actions. We need a new kind of bioplastic, which is both biodegradable and carbon dioxide neutral. So I mean that the plastic should not release carbon dioxide while being produced. There are basically two ways to deal with problems caused by bioplastics. The first one is to reduce the amount of plastics we use, but it's very difficult, and we have already experienced lots of failures in this way. Then, the next solution is to produce some sustainable bioplastics. So here, we found our needs for bioplastics. Then let's move on to the next part. What do we mean by bioplastics? What is it exactly? We can guess it from its name, bio. It's very simple. We produce bioplastics with agricultural crops such as starch, cellulose, etc. So here I just suggested some examples of typical bioplastics with this picture shown here. This way, it is very good for environment since it does not release carbon dioxide during the production process, and also they are biodegradable. However, crop-based bioplastics have one huge disadvantage because we have to use arable land, fresh water to produce it. So, the production of plastic with agricultural crops would result in considerable loss in agriculture and food production. In certain cases, arable lands become destroyed because of overuse. So, as you can see from this picture, we need some other materials to produce bioplastics. So in this situation, a promising new solution is microalgae based bioplastic, which is solar energy based. Here, algae is kind of creature that can perform photosynthesis just like plants, so it can provide us with energy to produce plastics. And unlike crop-based bioplastics, this microalgae, this solar energy-based bioplastic can be produced even in non-arable land. And since it recycles saline and wastewater for production, these resources are used for the production of such a plastic. So, solar energy-based bioplastic is biodegradable, as shown here, and carbon dioxide neutral, and even good for agriculture as well. This is quite a better option, right? Also, this new solution is economically promising since it can provide us and society with new market opportunities, with new supply and new demand, since this is the concept that was unknown in the past times. In both cases of bioplastics, whether it is agricultural crop-based or solar energy-based, we can use a variety of polymers and monomers as ingredients. So this is the table listing such examples. And such a variety means we can make use of various physical characteristics of such ingredient by artificial modification. So in this case, we chose degradability as a target property. Now, one thing to note is that bioplastics include not only biodegradable plastics, but also non-degradable plastics as well. So, let's take a look at both of them for clear understanding. First, for non-degradable bioplastics, as we can clearly guess from its name, it is not degraded naturally, so left as waste in the environment. Still, it proves to be very worthy since it can reduce the amount of carbon dioxide released. In other words, carbon sinks. So, with this type of bioplastics, non-degradable bioplastics, we can replace petrochemical ingredients with much more environmental friendly ingredients, and thus achieve carbon dioxide emission reduction within quite a short term. Now then, let's go through the degradable bioplastics. So first, how can you define degradability? Well, here, let's take a look at the international standards as shown in the table here. So here, we take time scale, mass, and concentration into consideration. For time scale, more than 90% of the wasted plastics must be converted to carbon dioxide and water within 180 days. And for mass, the remaining dry weight of the plastic must be less than 10%. And finally, for concentration, the metal concentration of the plastic must be less than 50% of the standard level. In addition, these standards must be satisfied regardless of the location. So, it must be degraded without any toxic bioproducts in industrial composters, terrestrial, and also at the aquatic systems like oceans. Now, we need what the bioplastics and now we know what the bioplastics and degradability are. So, in these days, steady development of bioplastics is being achieved. So this time, let's briefly summarize its advancement until now. At the early stages, so in phase 1, the keyword was sustainability. So, scientists and engineers just focused on the way to replace petrochemical ingredients with plant or crop-based monomers and polymers. The major target was to reduce the amount of carbon dioxide released to the atmosphere. So most bioplastics was produced using plant materials, and then they were blended with petrochemicals for commercial and mass production. However, in this stage, bioplastics still had many flaws because they released some microplastics and some harmful bioproducts while degraded. So, at the next stage, phase 2, much broader ingredients were used for the feedstock of the bioplastics. So at this moment, new types of plastic blends were possible, and therefore, the production of bioplastics was expanded and diversified. They had much superior physical properties than before, such as UV resistance or biocompatibility. So, they came with much higher commercial values. Then, at the phase 3, that is, at the most recent stage, as I mentioned before, we are now using microalgae or cyanobacteria as feedstocks. So, ingredients are becoming solar energy based. Therefore, agriculture or forestry are not disturbed anymore. And furthermore, the productivity is surprisingly high these days, since about 90% conversion from raw material is achieved. Now that we have gone through all brief information about green bioplastics, we will move on some concepts that can support the production of degradable bioplastics. When we produce bioplastics, we must take economic feasibility into consideration. To achieve it, we convert feedstocks such as crops, microalgae, or cyanobacteria into methane, CH4, and then convert methane into something industrially useful products such as protein, lactic acid, ethanol, etc. In this case, we can significantly reduce capital and operational costs because conversion to methane is quite cheap. However, it has one very big disadvantage because this process uses quite large amount of solar energy or biomolecules, and thus very, very consuming. It uses lots of resources as ingredients. Still, conversion to methane is a very good approach for the market profit. And also, we can consider biorefinery approach for the next step. So, we break down biomolecules into their components based on mechanical cell cracking or hydrothermal liquefaction. Then, cells will be decomposed to its constituents such as proteins, lipids, carbohydrates, and nucleic acids. Then, if we feed some feedstocks such as cyanobacteria or microalgae with such streams, these constituents can be used to produce a wide range of bioplastics. So, the bioplastics can be expanded and diversified. One thing to be careful is that this approach takes quite a high cost for operation. So, it's very expensive, and thus, we mainly produce only high-value products such as plasticizer or lactic acid with this approach, because we just cannot afford too much cost with this approach. And next, finally, these days, we are now using genetic engineering technologies to enhance the productivity of bioplastics. For example, we use CRISPR technology which cut off some unnecessary genes to maximize the efficiency of the production. In this case of plastic production, we use CRISPR to optimize light capture efficiency and biochemical pathways. It is very cheap process, so it's kind of GMO to improve both efficiency and cost. Okay, this is it for my presentation. So, as a conclusion, let's look at the brief summary. Until now, we have taken a look at the overview of the bioplastic, especially the one that can use solar-driven photosynthetic process for production. In this case, plastics are biodegraded and carbon dioxide neutral, and thus very environment friendly compared to past times. Also, solar energy based bioplastics is especially efficient in that it doesn't disturb agriculture or forestry and recycles resources as its ingredients. That's quite increasing, right? And with the aid of genetic engineering technologies such as CRISPR, as I introduced before, the productivity and efficiency and also diversity and quality were even more enhanced than ever before. Now, with the production of solar energy-based bioplastics, we, human beings, can expect to establish sustainable, renewable, and circular biosystem and economy. This is the end of my presentation, and thank you for listening.